Well, good morning everybody. Today we are learning 3-2 linear functions, and this is day 1 of the lesson. Your homework will be on Pearson's, and this will be a easier lessons because most of the things that we have learned or most of the things that you will learn in this lesson have already learned in previous lessons, such as in chapter 2, as well as solving equations and graphing a line, things like that. So because of that, there's no review sections for this particular lessons. We're going to go right into the lesson. So linear functions, in the past we learned that you could graph a line when it's y equals 2x plus 3, right? The slope is 2, the y-intercept is 3, so I would assume you would know how to do it by this point. Likewise, if it's y equals 4x minus 5, the slope is 4, the y-intercept is negative 5, so you will know how to graph this line. Well, here's the thing. In a problem when you have too many equations, it's really difficult for me to specify which of these lines I want you to graph because they're both called y. So instead of calling every single line a y, we have to give them a different name, so that way if I refer one particular equations or slope-intercept form, you know exactly which one I'm talking about. So instead of naming each of the equation y, we're going to call them f of x or g of x. So the way that you say it, it's f of x, the word of or g of x, and then this will be like a c of w and p of d, things like that. Okay. Now this does not mean multiplication. This does not mean f times x. This does not. Likewise, this is not g times x. It's just a name. There's no multiplication. There's no pandas, things like that. So instead of using a y, we call it f of x. And this x inside tells you that this function has the independent variable of x. And that's why it's called f of x. Likewise, for this equation, we call it g of x because g is just a name, and the x inside the parentheses tells me that this equation has the independent variable x as something that you will plug it in later. Okay, so likewise, if you have an equation with a w, which we have seen before in the previous lesson, then we want to give it a name. You could say c of w. So c is the name of the equation, and then w is just the independent variable for something that you would like to plug in case if it wants you to find some, answers. And then same thing, for this equation, d is your independent variable or your input, p is your output. So we'll call it p of d, where p is the name of the function, and then d is the independent variable of this equation. So in general, function notation is just nothing more than giving names to different equations if you see them at the same time. Okay, so that's a function notation, and I'll just write it on the screen. Function notation. Okay, so in example 1, we're going to get used to looking at function notation. So in part A, it says f of x is equal to 5x minus 4, and then they want you to find out what is f of 1. Well, f of 1 means when the x equals to 1, what is the y value? So all you have to do is rewrite the equation 5, and then instead of an x, you're going to replace it with 1, like this, and then minus 4. So you have to use pandas. 5 times 1 is 5, and then 5 minus 4 is 1. So that means f of 1 is going to be 1. Let's do a couple more. F of negative 2 means if x is negative 2, what is the output? What is the y value? So you're going to do the same thing. We write this equation, so 5, and then instead of writing an x, you're going to write negative 2, and then minus 4, like this. So using order of operations, you're going to multiply 5 and negative 2 to get negative 10. So then negative 10 minus 4 would be negative 14, and then that's the output. When x is negative 2, your y is negative 14. Let's do one more. If f of 1/5, that means you're going to rewrite the function 5, and then instead of x, you're going to replace it with 1/5, and then minus 4. So 5 times 1/5 using decimal calculator, you get 1, and then 1 minus 4 is negative 3. So therefore, when the input is 1/5, your output is negative 3. Let's try another example, example 1b. In this case, my independent variable is m, so g of m is equal to 3 times the quantity of n minus 2. Well, g of 2 means when m is 2, when the input is 2, what is the output? What is the y value? So you're going to rewrite this equation 3. And instead of writing an m, you're going to put number 2 and then minus 2. So you have to use pandas. So 3 times 2 minus 2. You have to deal with parentheses first. So 2 minus 2 is 0. And then 3 times 0 is 0. So when the input is 2, your output is 0. Well, what about g of 0? Then you're going to do the same thing. You're going to rewrite the function 3 times the quantity of 0 minus 2. And then 0 minus 2 is negative 2. So 3 times negative 2. And you will get negative 6. So that means when your input is 0, your output is negative 6. Let's try one more. What about g of 5? That means when m is 5, what is the output? So you rewrite the function again. So 3 times 5 minus 2. So 5 minus 2 is 3, and then 3 times 3 is 9. So when the input is 5 for this function, your output is 9. So that's how you find the output, find the answers when you're given independent variables in function notation. In example 2, we're going to talk about how do you find equation of a line when you're given a table. Now, instead of writing an x and y, x and y, x and y like this, you notice that I don't use y anymore. I use f of x. So in this table, the name of this table is f of x. The name of this table is g of x. The name of this table is k of x. And the name of this table is b of x. Okay? Now, you have learned it before, you've done it before on finding the equation. So first, to find the equation in slope-intercept form, right, we're going to first remind ourselves, for slope-intercept form is y equals mx plus b. So to find a slope, you have to find a pattern on the x and the y. So I know that in part A, the pattern for the x is keep adding 1. And then for the y value is keep adding 4. That means your slope is 4 over 1, which is 4. Remember to flip these two numbers upside down to get the slope. So you notice that the slope is 4. That means your equation is going to be y equals, your m is 4, 4x. Then what is your b, your y-intercept? Your y-intercept, remember, is always the y value when x is 0. So in this case, this is your y-intercept, because when x is 0, the y value is 3. So it's going to be y equals 4x plus 3. So this is the equation. But of course, when you write your answer, you have to change the y into function notation. So you're going to write f of x is equal to 4x plus 3. And this will be your correct final answer. F of x is equal to 4x plus 3. Let's try another one. We're going to do the same thing by finding patterns in a table to find slope. So in part B, I see that the pattern for the x is keep adding 1, so plus 1 and plus 1. And then for the y, I see that it's subtract 5 from one y to the next y. So that means the slope is you're going to flip these two numbers upside down. You're going to get negative 5 over positive 1. So negative divided by positive is negative. So that means your slope is negative 5. That means your equation is going to be y is equal to, your slope is negative 5x. And then again, your y-intercept is the y value when your x is 0. So in this case, it's going to be 4. So it's going to be negative 5x plus 4. And then your final step is replace your y with a name, which in this case is g of x. So g of x is equal to negative 5x plus 4. And that is the equation of this table. Now, of course, to check whether your equation is correct or not, on the test or quizzes or when you do it by yourself, simply just plug in all these x to here. And once you do some pandas to see if you get all these y's. Like, for example, if I plug in 1, am I going to get negative 1? Let's do this mentally. So when x is 1, 1 times negative 5 is negative 5. Negative 5 plus 4 is negative 1. Hey, it matches. So therefore, you know that this equation is the correct equation for this table. Let's do a couple more. So in part C, I'm going to find a slope by finding the patterns for the x, which is add 2 every time. And then for the y, it looks like I add 4 every time. So the slope would be positive 4 over positive 2, which is positive 2. That means your slope-intercept form is going to be y is equal to 2x. And then again, your y-intercept is the y value when x is 0. So it's going to be this number, so 2x plus 5. And then at the end, you change the y to the name. So k of x is equal to 2x plus 5. And then that's it. Okay? Now, of course, this is getting repetitive. We finally get to the last one, which is part D here. Well, in part D, same thing. We first find the slope. I see that the slope is plus 1 every time. And then for the y, well, for the x is plus 1 every time. And then for the y is plus 3 every time. So your slope here would be positive 3 over positive 1, which is 3. That means your slope-intercept form is going to be y is equal to 3x plus, I'm actually missing something. I don't see 0 for x. I only see 2. So you know what? It is your job to actually continue the table. So I know that when x is 1, I'm going to subtract 3 on the other side. It becomes 0. When x is 0, I keep subtracting 3 and I get negative 3. So this number will be your y-intercept. So it's going to be 3x plus negative 3. And then at the end, you're going to rename the y with b of x is equal to 3x minus 3. And this is how you find equations in slope-intercept form when you're given a table of values. Well, in example 3, we're going to review how to graph something in slope-intercept form. Instead of me giving you a y equals x minus 2, I don't write y anymore. I write it in g of x. So, but the way that you graph slope-intercept form has not changed. So first, to find the slope, I know that the slope is the number in front of x, which is 1. And I could write 1 over 1. And since this 1 is positive, is 1 up. And since this 1 is positive, is 1 right. And then your y-intercept is at negative 2. So that means I'm going to, on the y-axis, find negative 2 here. And then from there, I go up 1, right 1. So up 1, right 1, you put the dots. Up 1, right 1, you put the dots. And you continue that. And from there, you see that there is a straight line already forming by these 5 points. So you're going to use a ruler and then connect them to create your final graph. Likewise, in part B, instead of me writing a y equals, I'm going to replace the y with h of x, so that way I could give this function a name. So h of x is equal to negative 1/2 x plus 3. Well, in this case, your slope is the number in front of an x, which is negative 1/2. And then your y-intercept is positive 3, right? Let's go back to the slope. Well, let's decide that I want to put the negative on the top. So since it's negative on the top, on the numerator, it's going to be 1 down. And then since the 2 is positive, it's 2 to the right. So to graph this, I'm going to start on the y-axis. And I'm going to go up 3 times to the number 3 because it's positive 3 on the y-intercept. And then from there, I go 1 down, 2 right. So I go 1 down, 2 right like this, 1 down, 2 right like this. And then you notice that these 3 points form a straight line. So you're going to use a ruler to connect them. And then that's how you graph slope-intercept form, just the same thing as you did in the previous lesson. Well, the last thing I want to talk to you about is example 4, which is not exactly, but very similar to the problem number 14 on your Pearson's homework. Well, in problem 14, you see something like this. If your g of x is this equation, a very long equation, what is g of 2 plus g of 4? Well, to find g of 2, you first rewrite this equation. You're going to replace all the x you see with the number 2, and then minus 1 plus 2, and then 7 minus 2 like this. And then use order of operations to simplify these expressions. So g of 2 will equal to, let me see, so 2 minus 1 is 1. So 3 times 1 plus 2 times 5 like this. Well, 3 times 1 is 3, 2 times 5 is 10, then 3 plus 10 is 13. So that means g of 2 is 13. Well, on the other hand, I also have to find out what is g of 4. So let me just draw a line like this. So g of 4 will be 3 times, and then replace the x with 4, and then minus 1, plus 2 times 7 minus 4, and then close parentheses. And then again, use PEMDAS. So that means it's just saying this 3 times 3 plus 2 times 3, like this. Well, 3 times 3 is 9. And then 2 times 3 is 6. So 9 plus 6, you get 15. That means g of 4 is positive 15. Well, if I were to ask you to add these two, g of 2 and g of 4, I know that g of 2 is 13, g of 4 is 15. So you just add them. So g of 4 plus g of 2, actually I wrote them backwards, but it's the same thing. It's going to be 15 plus 13, which is 28. So 28 will be your final answer for g of 2 plus g of 4. Okay, let's do one more, right? G of 6 you first need to find out what's g of 6. So I'm going to rewrite this whole thing. So 3 times, and then 6 minus 1 plus 2 times 7 minus 6, like this. And then you're going to use order of operations. So 3 times 5 plus 2 times 1. And then from there, 3 times 5 is 15. 2 times 1 is 2. 15 plus 2 is 17. So that's g of 6 there. So g of 6 is 17. Well, likewise, you're going to find out what's g of 1. Well, g of 1, so I'm kind of repeating the steps. So you do 3 times 1 minus 1 plus 2 times 7 minus 1, like this. Then use order of operations. So you have 3 times 0 plus 2 times 6, like this. Then 3 times 0 is 0, 2 times 6 is 12, so 0 plus 12 is 12, right? And this is g of 1. So finally, g of 6 minus g of 1, so g of 6 minus g of 1 is just same as 17 minus 12, so 17 minus 12 is 5. That means the difference of those two output is 5. And this is how you would do problem 14 on your Pearson's homework. And this is the end of the lesson. So the next couple minutes will teach you or remind you how to log into your Pearson's homework. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks, so if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step, step by step, step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So well, to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So we click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that is not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it, and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.